Okay, everybody. Welcome, everyone, to the first lecture of our AA's lecture series this term. I have the pleasure, my name is Theo Spyropoulos, director of the DRL, to welcome tonight's guest, who generally doesn't really need an introduction in this school, Mr. Greg Lynn. Greg is very generously come straight off the plane to come and have a conversation with us. So we're going to try to keep this a bit fast-paced and conversational. The conversation is going to be based around an initiative that the CCA has been working with Greg on the issues of digital archaeology. It's part of a product. This is the first publication of a series of 3 exhibitions, events, and cultural initiatives where the CCA and Greg are actually looking at the problematics around the digital, particularly within a certain window in the mid-'80s to early '90s in digital culture within architecture. Greg, amongst his many accolades and teaching commitments, is one of the people that's probably most able to address this from a particular period of time within his balance of a research practice that he runs, Greg Lynn Forum, and through his teaching initiatives in schools like UCLA, Angewandte in Vienna, and Yale. The conversation tonight that Greg would like to sort of open up is basically looking at 4 projects by architects that he'll name, the likes of Peter Eisenman, Gehry, and etc., that are basically fostering a certain kind of research initiative behind the way that their practice has evolved, and at the same time coincided with a bit of a digital revolution within architectural practice, software, conceptual, intellectual engagements, and so forth. Greg's basically going to give us a talk for about 40 minutes, and then we thought that we would have a little bit of a conversation to spearhead a discussion and a dialogue with all of you today. We're going to try to keep it to an hour 15 minutes tops. And with that, I'd like everybody to warmly welcome Greg Lynn to the AA.
I expected about 10 people here, so I hope you're not disappointed. This isn't really my core competency. Helping institutions and curating shows. I think just what I wanted to start with is, like, why would I be doing this? And I'm hearing from, historians are also asking, why is he doing this? Why am I not doing this? And it is, I think, partially just because of familiarity I have with some of the material. It makes me feel very old, actually, talking about the digital in terms of archaeology and antiques. But the reason that this whole initiative started with the CCA, it really started when they acquired a project I did in the 90s called the Embryological House, which actually the AA was a very kind of central part of that whole discourse. There were some conferences here that were very important to my generation, where developmental biologists, physicists, people from the Santa Fe Institute, people from the City College here, all came together and looked at science, digital technology, architecture. It was kind of a very interesting moment. Anyway, when the CCA acquired the Embryological House, I very innocently said to them, because they said they wanted everything. And I said, well, do you want the digital files? And they said, yeah, sure, we want give us a whole hard disk, because that's how the CCA is. They want everything. They want your books, they want your accounting records, they want your sketchbooks, your notes, everything. Because the CCA it's a museum, but it's an institution that's really dedicated to scholarship and visiting scholars, and they're very interested in archives for the role it could play for future scholars. So they took everything, and then the nightmare for them began, because it turns out even 8 years ago, most of the software was defunct. Most of the hardware it ran on was barely running. All of the things you could save, which was just the geometry, like the kind of industry standard 3D data, it lost all of the expressions, all the parameters. I mean, I'll show some of that stuff. So anyway, it raised a whole question of what do you do with digital content as an archive? And they then undertook an initiative with the Library of Congress, with Avery Library, and with the Langlois Foundation, and spent 2 years on what they called devices of design, where they looked at issues of archiving digital material. And they started off with the assumption that anything needed to be saved for 100 years. And they found out there's really no information content that's been saved for 100 years other than print. So even phonograph records weren't 100 years old. So they tried to look at how to save the material, and they took two paths. One is taking the hardware and keeping the hardware running for 100 years, which is impossible. The second was to write emulations of the hardware and software and migrate it every few years, which is the strategy most institutions are taking. But anyway, it raised the whole question of what's important information and what's not. I think the other reason I'm involved in this is that I'm on that transitional cusp where I like to draft and used to draft a lot, and then started using digital technology. And so I was just around when a lot of that stuff happened. First thing the CCA did was send me this picture of me. That's in 1986. I'm on the left. You can see Mark Wigley sitting down there. He was working in Peter's office with me while I was there. You see Peter, and that's on one of the projects that's in the CCA collection. That was for the Frankfurt BioCentrum. But you can see there's a lot of physical models, there's a lot of drafting. I'll talk about that a little bit later. But so I was just around, and I was around the Lewis House and things like that. So I think that's part of the reason that the CCA asked me about this. In terms of the transition, I think it's very important to know that the digital tools, like a spline, this is a spline. And when I was in graduate school, I used to have a collection of these splines. And at Princeton at the time, a bunch of people started picking them up. There's all kinds of different ones, but a spline is for drawing. You can see that's a boat, the keel and hull of a boat up above. But you'd use it, civil engineers or naval architects would use them because you could draw a coordinate point, locate these ducts, these splines, the leads, and then a curve would be generated smoothly out of those points. And it was something you could scale. So you'd have splines at different scales, and you'd locate the coordinates in XY space, and then you could draw curves in a reproducible way. They were also described with calculus equations. It really was a very direct transition from this mechanical drafting device to the digital spline networks that everybody used or uses. But the digital technology did not come from some other place, and architects inherited it and started kind of banging on keyboards, which is really the discourse that I think is what the historians to this point have said, is that a group of people my age at Columbia University, some people in the Netherlands, kind of isolated groups of people inherited this alien software and started experimenting and discovering through happy accidents all kinds of techniques. Well, that's actually not how it happened at all. And really this whole program at the CCA is to correct that with facts. Like, I'm not interested in writing the history, I'm just interested in capturing the facts. So for me, this kind of drafting, and just if I could shamelessly promote a show at the Art Institute of Chicago right now, there's a show of my drawings of this Sears Tower project where I'd been using a computer for about 8 years and was using it for spline modeling, but was also drafting. And I found myself in Chicago in a one-room studio apartment teaching for the first time, and thought, I'm gonna draft my last project. And so for this exhibition that Stanley Tigerman set up, I thought, well, I'm going to draft what I would otherwise computer model. And I spent about 3 months, maybe 10 hours a day, doing these 24 drawings of the 9 tubes of the Sears Tower, kind of located along Wacker Drive. And all of them are done using projective geometry. So I draft them all in plan and then draft them in section and project the rotations back into the plan and then back into the section. So everything goes in kind of X-ray plan view and an X-ray section view. But it was really drafting what I knew the computer could do, because I'd already worked on the Cincinnati School of Architecture and Design for Eisenman, so I knew what you could do by iterating blocks along splines. But I wanted to draft it just because I knew it was the last time I'd ever draw. With embryological house, the typical thing that a museum would collect, ironically, would be sketches, which there were sketches, and models, which there's, it's in the tens of thousands of models for this project because it was mostly modeled using machines from, 3D prints to vacuum formed kind of CNC molds, which the CCA took, but they also took the underlying geometry, as well as, this is a view from a Microsoft Excel file where we wrote a little routine where we could take 3D data, drop the coordinates into Excel, and explode volumes into, you can see up there, 8 different surfaces first, and then we could explode those 8 different surfaces into 64, and then rotate all the coordinates into a flat plane, so we could then reloft all those things into these big sheets. So anyway, they took the Excel files, they took the 3D files, they took all the animation files, because all these things were modeled using an expression editor in Alias at the time. They even took the website. So this is a website from like 1998 or something. So they also kept the website. So they really tried to take all the digital data as well as the other information. And this has really been the kind of mantra for this digital archive. Okay, so the CCA decided to build this archive, and it's linked to a series of shows, the first of which is up right now. It comes down 27th of October, and then it goes to the Yale School of Architecture Gallery for 4 or 5 months, and then it's coming to Europe. We decided to not focus on architects or practices, but to focus on projects. So for this first round, they're collecting 25 projects, and they're collecting the digital materials of those 25 projects. There's other materials that go with the digital, and for the exhibitions, if they have to borrow it from other institutions, they will. But the real focus is collecting the digital, native digital material. When we came up with a list of 25 projects, there were 4 that not only were the earliest, they also stood out because the 3 of the 4 were like chronologically older than everybody else, and even Chuck Hoberman is kind of old at heart. So there really was a generational gap that we saw, as well as the fact that these 4 projects were very far ahead of other work. And I think what was the most shocking to me is that the narrative you hear about digital technology, again, being these kids at the attic of Columbia University, just totally false. I mean, that's a history that's been told by Hani and me and whoever, Bernard. We've all perpetrated that history, but it's actually a farce. What really happened is a bunch of people in their 60s went to digital technology with a plan and with a set of ambitions, and used the digital technology to execute on their ambitions and on their vision for design. And these 4 projects have a lot of things in common, but they also stake out what I think are 4 very different trajectories. One, using the computer as a procedural modeling tool. which is the BioCentrum by Peter. The other is using the computer to animate robotic structures, transforming structures, which is Chuck Hoberman. The third is using digital technology to optimize and produce structurally expressive force diagrams physically, which is Shoei Yoh. And then the fourth is looking at digital technologies and the language of digital modeling and finding its corollary in architecture, which is the Lewis House. Like I said, there are common themes that run through all four, but there's also these four different trajectories which are very linked to the architectural ambitions of the architects. And I think you see these themes in the next 21 projects crisscrossing through everybody's work. So, which I'm not going to talk about those, but that's how it kind of unfolds. So we tried to keep it to 4 projects: the Lewis Residence by Gehry, the BioCentrum by Eisenman. With Chuck, we included 2 things. One is the expanding sphere, and the other is the iris dome. And with Shoei Yoh, there were 2 gymnasium competitions done the same year. One of them was built, and we decided to include both. So Galaxy, Toyama, and Odawara Gymnasiums by Yoh. All projects were conceived in the late 80s. All of them were completed by the end of the 80s, maybe early 90s, depending on how you look at Chuck. So the way these 4 projects were approached was very different. I think in terms of collecting, like I said, I'm not trying to theorize this work. I'm not trying to historicize this work. We've very much taken it out of a narrative context. Instead, we're looking at core samples, so specific projects, not an oeuvre by an architect, not how those projects relate to their whole work, but just really focusing on these kind of core samples. What we did is we interviewed the architects, which you can see all the videos online. We also interviewed the collaborators in their offices. We interviewed the software developers, the hardware developers, the clients. We interviewed everybody who is still around, and just to build up an oral history of facts. We inventoried all the equipment they used, from the software to the hardware. We inventoried how much it cost, what its capacities were. We also tried to compare the digital to analog techniques, which you'll see in the show. But anyway, we were really just looking to collect facts. Because what I really see is there's a lot of misconceptions about digital technology and a lot of histories which are looking at obscure connections, but there's actually not a lot of material to study. I mean, you can't write the history of these projects if you don't have the digital archive to look at. So we try to kind of avoid inferences. So this is just a list of some of the people that were interviewed. This is in the catalog. These are transcribed. There are other people that are interviewed that are just in the archives. Turns out there's a lot of video, well, a lot of recording, and like Hoberman, his projects had something like 2,000 hours of videotape associated with them. So in the first gallery, I thought the best thing to do was kind of confront these 4 different trajectories to each other. And so we had 4 objects, and then we had 4 plates. So when you come into the gallery, this will be different in Yale, but when you come in, there's these 4 models. Peter's model, which is in the kind of bottom of the frame, of BioCentrum, Chuck Hoberman's iris dome, which is a robot, moves, it's all motorized. A model of the roof of the stadium by Shoei Yoh, and then one of the latest models of the Lewis House by Frank. And then the 2-dimensional image for Frank, it's a sketch. For Shoei Yoh, it's a photograph of acrylic under stress, so it's a kind of photoelastic stress diagram. For Chuck Hoberman, it's his 25-page US patent application. And for Peter, it's a hand drawing of a code. So there's common threads that run through everything. I think all the architects were worried about how the digital could be used conceptually, how it was more than a tool. I think all of them were concerned about authorship, like how they would use it as part of their medium rather than just using it as a tool. And I think they also were very clear about what would constitute mastery of the digital technology. So they weren't experimenting. There was no randomness to this. It was really, they would set an ambition and they would know what would constitute mastery of that ambition to some extent. So for the BioCentrum, this is the project which expresses this kind of procedural model. What's very funny is, you know, I worked on this project and I've known Peter forever, and when we interviewed Peter, he said, why are you using this project? We didn't use a computer on this project. And we said, no, you had a supercomputing center at Ohio State working on the thing the whole time. He said, no, I drafted, I have the sketches of it. He didn't even remember there was a computer involved. So the first things that are in the gallery are these sketches and diagrams by Peter. The first is this Xerox of a notation system for enzymes that he thought would relate to the kind of DNA coding. And those figures ended up becoming the figures he composed on the site. The other is this drawing, which this is the drawing that's in the main gallery, which is a whole sequence of those figures labeled, which he first fed into this custom computer program. And Peter was teaching at Ohio State and was working with a professor there named Chris Yesios, and Chris wrote a custom piece of software. And you can see here the descriptions of duplicate, rotate, and scale each one of those figures. Chris wrote a 2D script to do that, and later wrote a 3D modeling program to do that, and that later became a commercial product called Form Z. Anybody that's in the office that's probably over 35 would remember Form Z. It was like the Rhino of the 90s. It's the easy to use, kind of crush any problem, simple software. But anyway, Peter and Chris wrote Form Z on this project. So you don't really think of Peter Eisenman as a very digital person, but he actually was associated, if not responsible, for writing the industry standard 3D modeling software in the 80s with this project. The project was done, like I said, between a supercomputing center at Ohio State, where they had a Cray machine which cost $6 million and had 256K of memory. And Ben Gianni and a group of young professors at Ohio State were kind of teaching with Peter and supervising that. And it was the year that you could get a FedEx package delivered almost anywhere in the United States. So FedEx had been around, but it was the first time you could have the FedEx envelopes delivered. And so I remember while working for Peter, I was drafting these iterations of these figures with an adjustable triangle while the supercomputing center in Ohio State was doing the same thing. And they would FedEx us a package that we'd get every single morning. So before that, everybody used copy machines that could enlarge, which in '82, I believe, was when Richard Meyer and Peter Eisenman both bought enlarging and reducing copy machines. But a lot of the computer technology came out of this idea of being able to layer and superimpose and copy drawings. So the FedEx was sending things at 8.5 by 11. We would blow up those things and then compare them to what I'd been drafting that same day. And I remember humming to myself this John Henry song all the time. It was stuck in my head. It's this American song about a railroad where one John Henry would drive railroad ties. And they invented a machine that could drive railroad ties. And John Henry said, I can beat that machine. And they went over a mountain, and John Henry beat the machine and then had a heart attack and died. But it was in my head. I really felt like I was racing this machine. Here you can see some of the digital plots. All of the algorithms, the software, and the digital material for this project was lost 3 years previously when Peter had moved his office. So nothing existed. We looked at regenerating the app. I mean, you could run it on your phone. It would be so easy. I mean, you could have somebody set it up fairly simply, but we decided to just keep all of the digital plots, of which there were tubes and tubes. So, like I said, there's all these FedEx plans. So these are the digital iterations of those sequences that Peter would write. A lot of them have notations and notes, which would get faxed back and forth and FedEx back and forth to the team working with the computers. And like I said, at the same time, there was manual drafting, which was tracking it kind of at a parallel pace. So these are all planned, drafted drawings, which were trying to work the same thing out. In the end, the underlay was done by the computer, and then it was pin bar drafted over. These are the first 3D hidden line axons, I think, that I know of. This was before AutoCAD could draw in 3D, so this was the very earliest form of Form Z. Even CATIA at the time couldn't do a hidden line. They could only show you the wireframe. So, and then in the room, you'll see model studies, on one bay, the plotted, on the other bay, the drafted, and then extrusion studies to bring it into 3D, which were also kind of tracking the 3D modeling that Chris had developed, and then some real early perspective renderings, which you couldn't use hidden line drawings for, so those are all just wireframes. Anyway, people have been doing perspectives on computer before. There was never a program where you could design, model, and generate perspectives in one package. You always had to move it around. Okay. So, and then the one thing which was lost, which is sad, is there was a model that Tom Lacer had the idea for. Peter always worked with Bob Slutsky for color, and Bob Slutsky set the colors for this, which were pastels, and he dictated kind of how much white and gray to add to each color. And over a weekend, Tom decided to take a small model and paint every surface of the model a different shade of those pastel colors as if it was a computer rendering. And it was at the time that Tron, the movie Tron, was out. And so he was really going after a Tron aesthetic. And so the competition model was painted just like we would have Pantone shaded these drawings. So each face of every surface had a different tone. So when it sat in the room, it looked like it was lit from a particular direction. But it was the competition model, so as they were sending it back to MoMA for the deconstructivist architecture show, the German customs officials said, wait, this is German property, because it's part of the official competition, and they kept it, and then they destroyed it a week later. So anyway, it's gone. All the plans and sections and elevations were all drawn over digital files, which is same thing you'll see in Frank and Shoei Yoh. Okay, the second project in this suite of projects is really two. It's Chuck Hoberman's Expanding Sphere and Iris Dome. Now, Chuck, unlike Peter, was writing his own software. He was also writing it on the very first desktop Macintosh, and also on an IBM AT. So instead of using supercomputers, Chuck was using the very first generation of desktop computers. He also, through the whole period, was patenting everything. He holds 18 patents related to these two projects. And those patents ended up spinning into all kinds of things, from toys to robotic mechanisms. The way Chuck would work this out is he would write by hand all of the scripts, and he has notebooks of all of the scripts. So he kept a lot of the digital material, but most of it was actually in handwritten form. And we reprogrammed several of those handwritten routines and had them in the exhibition. He would then do manually drafted diagrams to show the rotation limits of certain joints. And then he really used the computer to figure out how to add material thickness to all of those, like what you would now call like a solid modeler, which could look at collisions and intersections. He was trying to solve between 2D drawings and hand scripted routines. Most of this was done in AutoLisp, which was the earliest kind of coding language for AutoCAD. Chuck would then take those mechanisms, and he'd worked for a company called Honeybee Robotics, which did the arm on the space station, the Canada arm on the space station. And with another employee from Honeybee, they would then manufacture using CNC router tables, aluminum, and sometimes small plastic laser cut prototypes. So Chuck was actually the first person I know in architecture which was doing CNC manufacturing back in the late 80s. So all these components, the aluminum components, were all CNC cut. And then for some of the things, he was also one of the first people to use 3D printing. I know in the States, New Jersey Institute of Technology had the first stereolithography machine, and I know I used to use them, and the only other person I knew was Chuck, who was printing a lot of these. So there are two models, which are all laser cut aluminum models, which are robotic, that are in the show, as well as a lot of video and footage of them in upstate New York. That's Bill Record, who was his partner in this, where they would CNC a lot of these components and build the prototypes. Chuck also, because of the folding and architecture AD and things, was very interested in engaging other architects, and did a whole series of studies of origami transformations like this. And one of those physical models actually has an origami skin on it that's pleated and folds. You can see the Mac Plus interface. So Chuck also had to write the software to 3D, to do hidden line drawings of his own origami studies. So that's not a off-the-shelf software, that's a custom hidden line software that Chuck made on a desktop computer in order to visualize the surfaces. Okay. And then also, like I said, we have a couple of the patents in the CCA show, but the archive has all of them. Okay, then in between the projects, we have this room which kind of inventories the equipment and also has the videos of the different architects. But it was really surprising to see, we could get a Cray supercomputer. They're inexpensive. I mean, they're less powerful than your toaster. But so this $6 million Cray supercomputer would have fallen through the floor of the CCA. It weighs like 3 tons or something like that. So we have pictures of that. But so on one end you see the Eisenman equipment, which has the Cray supercomputer. We found a 1987 FedEx envelope, the first letter envelope from FedEx. The fax machines, a Xerox copier. Then the Hoberman stuff, we have the IBM AT computer, and then you can see in the back the Macintosh 2 Plus. For Shoei Yoh, he was using Silicon Graphics machines from Hollywood, so that's a Silicon Graphics Indigo workstation. And then at the end, you can see the digitizing arm that Gehry was using, along with the IBM kind of desktop supercomputer at the time that they were using. And, you know, those are like, they're old guys. They were all, I think Frank was 63, 64, something like that. Peter would have been 59 or 60. Shoei Yoh was in his early 60s. So they weren't kids. I mean, they were all mature practitioners that went to the computer. Shoei Yoh came to the computer not through software, but actually through manufacturing. There's a space frame company from Germany that opened up a Japanese corporation for manufacturing space frames, all the way back in '68 for the World's Fair. And they had a system of ball joints where they wrote software. They have a German software which would calculate the angle and stresses on all of these ball joints. And Shoei Yoh found them and actually connected them with his engineer and used them for all of the digital modeling. So he actually came from a manufacturing end of things. But what he really wanted to do was capture the quality of snow loading, and was really invested in structural expressionism. So for both of these gymnasiums, they're these structural grids. The way he worked is drafted two-dimensional plans, which would kind of organize the program on the site with section sketches. And so there's a whole series of those 2D drawings. And then they would go into digital modeling, which was then run through structural analysis to relax the structural frame and develop depth wherever the loads were higher. And sorry, you can see in the plans that the column grid is not a normal column grid. The column grid is kind of based on the different fields within the gym. And that's what gives this uneven structural depth. So there really weren't a lot of models done. This is a kind of conceptual model. Shoei Yoh started with these photoelastic studies by Robert Mark and really wanted that quality of moire pattern. These are drafted 2D plans in CAD and some kind of early 3D models, again, from the structural engineer. So, and at Columbia University, before the paperless studio started, Shoei Yoh taught and did an exhibition of these drawings. And I know Hani and Jesse, myself, we all were very interested in this obscure Japanese architect that had this computer skill from these projects. So this really predates my generation's use of digital technology. That's one of those photoelastic studies. And now these are actual plan views of the structure, trying to get towards that image, that Robert Mark image. These are, diagrams of the failure of the structure and then the corresponding change in thickness. It's the same structural engineer, actually, that Ito used for Sendai. So we really were trying to be geographically diverse in our list of 21 projects, but it was very tough to find Asian architects using digital technology. Shoei Yoh is this weird anomaly who was there very early and didn't seem like people picked up on it in the 90s. So, and then finally, the kind of the nicest drawing, I believe, is the one on the lower right, which just shows every single ball joint in that space frame, and then those columns of text are each of the angles of each of the drilled points that go into that ball joint. So, highly parametricized construction technique. And then some very early shaded renderings. And this is the only project of the group that was ever built. So views of that complex truss. Okay, then the final project is the Lewis House by Frank Gehry. And to me, what was so much fun about this is we looked only at a 6-year period of the house. The house was an ongoing project for close to 10 years. But during that 6-year period, you really saw Frank invite in a digital approach and then find a way to either sketch or build a model of that approach so that there was some corollary. So he had done the fish gateway sculpture in Barcelona with Skidmore, Owings, and Merrill. Actually, as I understand it, the project was Frank's. the developer asked him to work with Skidmore as an associate architect, and by the time things were done, Skidmore, Owings and Merrill designed the whole complex, and Frank got a sculpture. So, I mean, that's what led Frank to say, look, this is never gonna happen to me again. I'm gonna get computers to give me the credibility so that I never get steamrolled by a big corporate firm like SOM again. So, SOM had an Autodesk 3D modeling package and structural analysis package and their own engineers. And Frank decided he needed something better. So he went to CATIA and brought CATIA in to do the design and analysis of this Barcelona fish. So for the Lewis house, one of the first things that happened in the design is he composed a bunch of those digital fish, just scaling them. He just changed the size and changed their orientation and built a CAD 3D model of a house built out of the Barcelona fish without ever really changing the shape. And for 2 years, you see physical models like these, as well as digital files. And this is that's the Barcelona one. But you can see that, you know, people like Craig Webb were drawing using radii and drafting techniques, versions of the fish to try to integrate it into their normal design workflow. So for a year or so, you see these fish getting sketched, getting modeled, you know, with wood models, getting composed on the site and site models, and all the while it's being tracked in 3D with digital models. So these are now point scans where they would draw lines on a physical model. Well, they would take the fish, they would slice it up digitally and build a physical model of it. They would alter that physical model, draw lines on it, scan it with a robotic arm, bring it back into CATIA, get this data, resurface it, and then cut it and then draft plans on it with what's called a pin bar, which I'm probably the only one that would remember these, but they were pre-punched Mylar sheets, and you had a metal bar on your desk, and you would register all your drawings. So if you did a plan, you would pin bar your plan and you'd put a section over it, and that way you'd know it would line up every time. If you handed it off to somebody, you knew your drawings would line up with these pin bars. So all these sheets were digitally printed on pin bar sheets and then drafted over with pin bar sheets. But you know, the 3D data was then fairly robust. So this is a bunch of those sliced up kind of fish shapes. The office called the four, which made it through the whole project, called the Sentinels. And you can see them there lofted in 3D surfaces. And then, you know, built out of vivisection plates that were then covered in Bondo and sanded smooth. At a certain point, they shifted from that to making wireframe models, which, and by the way, at this time, CATIA couldn't shade a view. It could only work in wireframe. So, you know, in talking to the people in the office in interviews, they said, well, we're looking at wireframes, let's build in wireframes. So they started building all these wireframe models until they figured out how to unfold surfaces, at which point then you see these unfolded surface models. So there's another language that evolves out of the simple innovation of a digital technique to unfold surfaces. Then they start trying to find the model corollary for all these unfolded surfaces. So these are now built with no structure. They're purely just plastic skins. And in Frank's sketches, you start to see him drafting like spline surfaces. You know, then the project takes on a totally different language of lofted, ruled surfaces, which is exactly how it was modeled. Then everybody describes a breakthrough where they see the shaded models for the very first time. And those are views like that. And so when they started to see the shaded models, which to my eye are, let's say, inelegant it is spline surfaces because of the way they were generated with all the point clouds. They then found a way of building physical models which had the characteristics of the lofted models. And I'm blanking on her name. She's somebody that I've never met, but somebody in Frank's office had the idea to put beeswax on velvet. And so those are beeswax covered velvet models that would hold their shape. And they could then take curves, model them in velvet surfaces, then scan them with the digitizing arm and generate lofted 3D surfaces out of that. So the whole time in this project, you see digital techniques being kind of lockstep developed with physical modeling techniques. So, and then the project takes on a totally different language of these lofted spline surfaces. But again, tracked by the velvet models, and even look at Frank's sketch at that point. I mean, he's sketching like a computer. I mean, it's really like a spline network doodle. And the physical models at the time then ended up getting into, I think, if I go back, now I'll show you, maybe the model in the first room, it's all built out of what's called LOM modeling of sheets of paper that were very thinly laser cut and then laminated together so it looks like plywood, and stereolithography. So these models then started to be more, let's say, 3D printed than hand modeled. And then these are drawings, these are now no longer pin bar drawings, but this is the first case. I mean, SOM was doing it with towers and things, but this is a case where the CATIA 3D model was brought into AutoCAD, and all of the plans and sections were then generated based on a 3D data set. It wouldn't update itself, and all of the information beyond, like in the roof plan, had to be manually drafted in CAD, but there's a fidelity between the 3D data set and the slices that are cut through it. So that's the first case of that. So anyway, you know, in conclusion, this first set of projects, these 4 projects in terms of digital archaeology, for me, really show a couple of things. One is that the speed of the computers was so slow at this time that physical modeling, hand drafting, even structural analysis on sheets of paper, or even kind of writing algorithms out by hand, were at the same speed of the processors. So when you've got a $6 million computer with 256K of memory, it means that the analog method and the digital methods were equal in speed, and you really went to the digital because you wanted something from it. It also meant there was a lot of correspondence back and forth between all these techniques. In the next round of projects we look at, which is maybe 5 years later than this, it's a totally different story, where the digital technology is much faster than manual drafting or physical model making. So either those techniques get abandoned or they get very divergent, where here the kind of dialogue between the stuff is very rich. I think the other thing, which I think is the most important correction to preconceptions, is that in each case, there was a vision and an ambition for what the digital would do. It was not some kind of quasi-art practice, which is, you know, that's the thing I've always hated, is this whole idea of the happy accident, that you're just playing with a black box and hoping something good happens and trying to notice when something good happens. This was actually driven by an ambition and a logic for the machine, not a logic, a sensibility for the machine, you know, which started conceptually and started creatively before the digital ever got to the table. So anyway, I think it gives us enough to talk about. So if anybody's got questions, the one thing I can't do is talk about the next 21 projects and the next 2 shows, only because we're in the process. I mean, we know what they are, but we're in the process of figuring out what materials we can get and who gets shown when, and so that'd be a mistake for me to talk about the other projects, but in general, I'm happy to talk about where this is all going.
Could I just ask if we could turn on the lights, maybe make it slightly more conversational? So just have, let's say maybe a couple of questions, just to kind of kick off the conversation. Because when I was listening to you, Greg, talk, it brought up a certain attitude that I found quite striking in relationship to a woman named Yasha Reichardt, who in the late 60s and 70s here was putting together a show at the Institute of Contemporary Arts, which was called Cybernetic Serendipity. And part of the interest that Yasha had was basically to look at the computer and a computer's role and relationship to the practice, not necessarily of art or science, but really trying to see almost like a litmus test of how different, let's call it creative individuals, regardless of disciplinary boundary, was working with the tool in a way. And the show for me was interesting for a lot of reasons, because it brought people who were from cybernetics background, people basically from Boeing that were using the first CAD systems to basically show different kind of postures of seating and that kind of development. And juxtapose that with, let's say, more well-known artists of the time. She didn't really clarify the distinctions between these people, but in a certain way, by putting them in the same room, made this work accessible. And in reading, let's say, some of the interest, let's say, from the CCA, I guess my question is more from the institutional perspective, especially after doing this first project. It seemed like there were a lot of informal relationships and tangents that in many ways were sort of triggering certain relationships that had affinities within digital processes. Mirko Zardini, when he's talking about it, is trying to sort of use a word like the digital. And I said, thinking about that has certain kind of connotations today. At the time of the 70s, for example, they were using software as the issue and the computer. And that, I think, has a certain history within this kind of experimentation with Architecture Machine Group, people here like Cedric Price and John Fraser. And Mirko tries to basically suggest that in a certain way, this isn't about that period. It's about this period of kind of digital infusion where technology wasn't at the forefront of the conversation, let's say, but obviously was the nature of, let's say, these kind of experimental projects and how they're sort of fostering certain things. It's clear for me with people like Peter and Hoberman and Shoei Yoh and for sure Frank that there were some kind of questions that the computer necessarily facilitated some features while maintaining that kind of creative fostering. For me, I just would like to get a sense in terms of this word, the digital, because there was a strong outline from Mirko to talk about the digital and the archaeology. And in terms of those two terms relative to today's practice, especially because a lot of this work is so ephemeral, it's interesting for me to kind of tease out what from the institution's perspective will allow this to be, let's say, accessible for those researchers and PhD people as it was, let's say, to do a show which just brought this work together in a space and allow people that sense of discovery and curiosity. I don't know if that kind of makes some sense.
Well, I mean, I think there's definitely 2 parts to the question. I think one, it is interesting to look at how the architects address the term digital or even, you know, the software or the hardware. I know here at the AA, I made this statement that I got pinned with a lot when I said that instead of all the time telling the computer what you want it to do, why don't you ask the computer what it wants to do, or something like that. I forget what the statement was. It was at this conference Charlie Jenks had.
I was sitting in the audience.
Oh, really?
Yeah.
Well, it seemed to have a lot of sympathy among my generation, and it was true. We were all frustrated by people saying why they didn't want to use a computer or what they wanted from the computer, and that they didn't have a working knowledge of it. And that for the people that had the working knowledge, it was really more about figuring out what it could do. This suite of projects and this moment in time, I think really was the architects telling the computer what they wanted. Although they were all people that had done the work to find out what the computer could do, so that that was an intelligent request. And so I would say, just in my anecdotal experience of this change, that there was a moment where everything was in the future. Like, you know, it was always in the future. We won't use paper in the future. You know, we're gonna be able to do everything in 3D, and we'll model with our hands. And I mean, there was all kinds of stuff about the future in the late 70s and early 80s about the computer, but not a lot of access to it. With both the desktop computer, which you see with Chuck, as well as with silicon graphics and things like that, and you know, the technology that was in the hands of structural engineers in the 80s. I mean, like Arup is only Arup because they invested in digital technologies that the architects didn't. That then there was this shift of, well, I know what a computer can do, and now I'm gonna tell it how I want it to do that for me. And then there was this other moment, which I haven't really had a look at yet, but that's what we're focusing on next, is when two things happened. You saw people going to the digital technology natively and trying to figure out if it could do something we hadn't thought of. And you also see theorists starting to say in the future again. And actually that's the thing when we were having conferences in Montreal, you know, the thing that drove us all crazy was the in the future, that we didn't want to have anybody say, in the future we're going to do this, that this is really looking back. And it's trying to sort out what had been done and what can be done, and not have this kind of promissory tone. And for me, that's the 90s. The horrible thing about digital technology in the 90s was the people that were the futurists that were promising what the computer was going to do, and architecture was going to be whatever, you know, liquid, interactive. I mean, all these things which were like journalistic terms, which put everybody in a weird box. So, but this generation didn't have to struggle with that, because they were, I wouldn't say practical, but very discreet in their interests, not generalizing. Also, there was no, I think for Eisenman, there was a cultural agenda in using the technology. I mean, he really wanted to make a genetically generated building. And that was a cultural mission, but I think the other architects were really not looking at the cultural statement of the digital at this point.
Yeah, no, I mean, one of the things, like, let's say, resonated with me was the project-based nature, which I think isolates a lot of these issues and sort of creates that kind of lineage, which I think many in the audience would understand based on their own sort of experiences. And I think many of us would sort of agree that the novelty of the digital is for sure past. But it's interesting to me in terms of the way that one constructs a history, particularly within the digital. I was interested because Mirko was basically talking about people like Lionel March, and you know, they have a certain attitude towards shape grammar language and these kind of things. Or mentioned Cedric Price, which the CCA obviously owns a big part of owns all of the archive. and there was an attitude towards the idea of technology, the partnership of technology. And he mentions, along with the participants is the equipment. And that I thought was pretty interesting, but in a certain way also problematized the complexity of the issue, because let's say in rooms like this, Price would say technology is the answer, but what was the question? And in some way, I'm kind of interested in what the CCA is trying to explore by virtue of holding these exhibitions in different kinds of formats. Is there an experiment on their side in terms of how to actually deal with this? Because I think, for example, information beyond the complexities of, let's say, the actual material is basically how people will be able to make it accessible and make sense to it. And that seems to be an issue that's not just within architecture and issues like new media and art, which is like over a 50-year-old practice, still has those kind of complexities. People are talking about the archive, but in ways of preserving. And there's a kind of preservationist tendency, which I'm curious about. Like, for me, what's really striking is the stories that go along with it. Like Peter, not fully conscious of the influence that, let's say, he had in the development of Form Z. And for example, you mentioned Ben Gianni. There's a part that I thought was quite striking, because the way that they interpreted the way that the project and the relationship with Eisenman was, he says he thinks in some ways we believe the mission was to find an architecture that would design itself. The building itself was going to be an expression of its own organic generation. And that kind of resonated with me a lot, because for many of us, we were trying to find ways of using computation, a different kind of category of, let's say, interpreting the digital.
Yep.
And it was kind of symptomatic, actually, with all the people that were being discussed, but he uses an anecdote that he said that Eisenman gave him some advice that the problem is you're designing. And basically, if you don't like the form, change the form through the process in a way. Mm-hmm. And because a lot of this work was very process-based and very time-based in a way, in a very slow unfolding, I think certain things became legible. In your, let's say, experience, particularly with the generations that were following them, and Peter obviously has had an influence in you and many of us, it's curious to me, let's say, what becomes the litmus test to sort of deal with a kind of archaeological discovery within the work. Let's say with the shows that are coming up, those parameters, I imagine, and those variables are changing. Not to talk about the particular people, but the context that actually would bind them together discursively. Mm-hmm. Is that something that you feel is becoming more obscure as the nature of the project is unfolding, or is that something that you see is sort of clarifying itself as the next generations become more embedded within that, let's say, digital culture?
Okay, well, so I should have taken a better look around the room. And I suppose this is on the web, which is, anyway, I don't want to get myself in trouble, but my assessment of things is that there's not a lot of intellectual work being done in the field right now. That there's, and especially with digital technology, it's become, there's a certain level of like vocational training that doesn't have the conceptual mission behind it, that I really, I miss like this generation and the generation after it, where there were big claims being made. Even if the claims couldn't be backed up, that there was a intellectualism and conceptualism that went with the technology. And I mean, one of the reasons I like the CCA is that's their first mission, is to do kind of scholarly intellectual shows. And I think it's partly because they're in Montreal. I mean, I don't know how many people have been to Montreal to see the show, but not as many as if it was in London or New York or something like that. So they try to be smart and have the ideas and the scholars take the stuff, disseminate, rather than the shows. And that just sets up a certain kind of an approach. So, I mean, for me, there's a couple of facets of that. I think one, the historians and theorists who were peaking in the 80s and 90s did not know and do not know the first thing about digital technology, other than the histories of, you know, where it came from and, you know, the machine. They know the historical facts. They don't know the intricacies of the topic the way they would know, like, how a perspective, like the difference between a 1-point and a 2-point perspective, any architectural historian is going to know. You know, the difference between Form Z and AutoCAD, they might not really know the first thing about why the difference would be critical. So I think the trend was to stop your historical and theoretical work right at the computer. So mid-century modernism, media, television, Playboy magazine, all topics for historical and theoretical work. Digital technology, don't want to put my toe into that for fear of showing up like a dilettante. So, I mean, there's exceptions. I mean, Mario Carpo, and there's a number of exceptions of people that are learning it. But I see this big void around this whole topic, and part of the agenda of the shows is to provoke that discussion. So I also think just that depending on what you collect, it really influences if you can have a concept. I mean, like, I don't know if you've seen the Corb show, but Jean-Louis Cohen has a very elaborate discourse about Corbu and landscape at that show. Now, I haven't met a single person that understands what that show has to do with landscape. And the problem is, it's a bunch of little models. And it's because it's rooms full of little models without a whole lot of supporting content. It's very tough to have a conceptual show. So I think one of the things that we all understood when we looked at this stuff is, how could somebody do work on Chuck Hoberman's dome if all they have is the models? You know, that you need all the other stuff. And I mean, the CCA has always been about that. They've always been more about this minutia and the tangential sketchbooks and the receipts from where they had lunch, and, you know, PhDs will go do work on that stuff and they'll actually find things out. But with digital content, that stuff's gone. I mean, so really the agenda was get the stuff collected and have it there as long as you can, but don't wait for industry standards. Because I think most institutions will say, you know, if it's a print, it goes into prints and drawings. If it's a photograph, it goes into photography. If it's in architecture and design, it's a model or a sketch. And so you'll see like Diller Scofidio collected as video at MoMA's, you know, video library. You won't see it in architecture and design. So CCA decided to not worry about all those boundaries between media, but just kind of get it all together and figure out what to do with it. And it's what's clear is there's no industry standard for any of this stuff. I mean, the Library of Congress, Avery, and Langlois are all trying to figure out how to set standards so different institutions will know what to keep and how to keep it. But I would say that's decades away from getting sorted out. But in the meantime, all the stuff is gone. I mean, it's really amazing how much the life cycle of the information you need to do the historical work disappears in like 5 to 10 years. I mean, the Gehry office, because of professionalism, kept everything saved on a daily basis. So when we took their digital archive, each file is saved with a daily date. Sometimes 7 days a week they were working. And then they have milestone files, so it's also pretty easy to know, well, this was the end of schematic design, so let's look at this. It's, you know, we don't have to go through every day's worth, but they have every day's worth. I mean, the CCA also, they built this machine, which is very badly named the Harvester. And every digital file gets ingested through the Harvester, and what it does is it compares it to all other files and tells you how different it is. and it searches for keywords to tell you what program it was written in and what the dates are and who the people were that had logged in and saved it. So they came up with this very basic thing, which you just dump everything into, and it gives you the most basic data. But they didn't make a commitment to like DXF versus OBJ versus, you know, IGIS, which is really what most of the institutions are talking about now is industry standards.
Maybe we could open it up for some conversation. We have someone right here. There's going to be a roving mic.
Hi, question. Back then, 30 years ago, when digital technology was in its infancy, you being you were there, what do you imagine the future would be of architecture?
Well, this is what I got a lot of. That stuff is never gonna take hold. Nobody's ever gonna be interested in it. You're never gonna see the day that people are gonna be using computers to design. It's really amazing how resistant the field was to any of this. And actually it gave me a sense of like that things didn't have to happen so quick. Like that I had the luxury of time when actually you found out that within like 5 years, every commercial office, everybody just absorbed the stuff and went much further than you would have ever imagined. You know, 20 years ago, would I think that, you know, Frank Gehry would have a 400-person software company? Like, I don't know if you know this, but Frank owns a software company that's bigger than his architecture firm. So would I have thought that? No. Like, I mean, so many things you would have never imagined becoming so accepted. So yeah, I was really surprised. I kind of thought digital technology would be this funny, niche preoccupation, and it ended up being just the most global, everybody uses it stuff you'd ever think of. So yeah, I was happily surprised at how popular everything became so fast.
Is there any other
So
questions?
what do you think is the most sophisticated software to use for architecture design right now?
Well, it's in the 90s, it was really important what software you were using. I mean, it really defined, let's say it was very much a collaborator in the whole creative enterprise and also the whole professional enterprise, what you selected. I think now it's maybe less of an issue. I mean, it's also, I remember, you know, I would have like alias for surfacing, I would have wavefront for anything that was expression based. We would have AutoCAD for everything 2D. But in the course of even a week, something would move between 4 or 5 different softwares. Now it's just like, first it was all like an Autodesk suite, and now it's just like your basic software kind of does a lot. So I don't think you need super high-end software anymore. I mean, I actually think what's more interesting is a super low-end. I mean, in terms of when I talk to software people about where to focus, I think focus on the MakerBot fairs and the people that are going to be printing 3D parts for their cars or their ceiling fans or whatever it is. I mean, I think that is huge. I mean, I really think everybody is going to need an architect for everything. I mean, in the same way you need an architect to work on your building, I think you're going to need an architect to repair your car, to, you know, order your jacket, your shoes. I mean, if you look at what Nike's doing right now, they really look at themselves as, you know, they call architecting shoes with digital manufacturing. So I think the lower end is more where the action is right now than the higher end, personally. But I mean, how we engage that as architects, that's a whole other question. Very interesting question, but.
I think it's definitely something that's turning over to how we compute things. I think having the software platforms now are very much kind of pretty shared and collective, and the ideas of cloud computing and different ways of processing information are definitely changing things. And then having these kind of more distributed making systems is obviously changing the way that at least we conceptualize this, how we actually do it, and what those things are. Obviously, also becomes a product of accessibility. And a lot of these people talking about 3D printing don't talk about the fact that, okay, that knowledge for people to actually make it every day will have to be sort of given over. So maybe that's the architect, or maybe that's a requalification of what the term architect will be, which for me kind of resonates again back to some of those early thought experiments about people who didn't really have access to some of this technology. And maybe some of the guys that you're showing today actually resonate some of that, where they may not have direct access, but through the office and some of those problems, those things were actually really being problematized in a way that one couldn't really forecast. Is there other questions? Yeah? Can you wait until the microphone? Oh, you got it already. Taven, you're fast.
Well, for me, what was missing from the conversation, I know it's deliberate because you haven't worked on it or you did not work on it. Is there a critique on the digital media?
A critique on.
Yeah, that's a critique, not necessarily something negative, but as a dissemination of what were the impacts, what was maybe a misuse of the tools or something.
Well, you can't do something like this without discrimination, let's say. So the selection of the projects is really important, and the historical period is really important. I think after those kinds of decisions, it really is more just trying to collect material and provoke a discussion. And frankly, like in the catalog, I mean, it could change in the future shows, but you know, there was a lot of pressure to write like a treatise or a historical frame around everything. And I was always saying, look, you know, I think that's the biggest mistake we could make. Like, we do not want to have this wrapped up with a bow and delivered as a you know, closed topic. Like, it should, as much as possible, be the oral histories, the weird collections of stuff, the, you know, juxtapositions of digital with analog, all of the stuff that is not typically presented, but without a whole lot of, not interpretation, but yeah, without too much of a critical assessment. Because it really is meant to provoke a generation of historians and theorists to engage the material. And really, I see that's what's the biggest vacuum in the field right now, is that people aren't engaging digital technology because they're not comfortable engaging it. But I think with, the, you know, if you put the information out there, people are going to start to interpret it and make all kinds of connections and things, so. But frankly, the architects are like their own worst enemies too. You ask Frank Gehry, like, what do you think of the computers? I hate the computer, I've never used a computer. You know, we just use it to document. I mean, meanwhile, we got sketches of Frank drawing like a computer. He's like the best computer doodler I've ever met. So, you know, he's got a giant computer software company that he runs. So, you know, but if you don't notice all that stuff and you just listen to him, you would say, oh, Frank Gehry actually just makes models and crumples paper and uses a computer to build them. But actually, the computer's like a creative partner. Same thing, you know, Peter Eisenman didn't even remember there was a computer involved in his project, so.
Yeah, you called Peter the father of parametricism?
Well, I think between Peter and Shoei Yoh, there's, you know, there's a whole lot of stuff that's still very current in those projects, which probably, you know, ironically is maybe not so current with Chuck and Frank. I mean, there it seems much more personal, although I think, I mean, so in fact, you're asking kind of what I think the big direction is, which I think it's, you know, dumber 3D for more people working in a cloud. But what I'm interested in is not that. I mean, but I'm out of step with where, I mean, I think where things are going is one thing, where I'm going is another thing, but I think robotics and all that stuff is real exciting. I'd personally put a moratorium on those interests myself in the 90s, and now I'm real interested in it now.
Can we get a last question? From Mark Cousins?
I mean, the question. The question's more sort of on the side of the archaeology, because as you go through the kind of materials and as you go through how the exhibition will be, I'm thinking it takes you all the time further and further away from what you might call traditional historical conceptions of kind of history conceived of either in a causal sense or a narrative sense. So it seems to me, in addition to like a certain resistance, for example, by historians, in a way they would have even more of a resistance if they realize what this is going to do to, in a sense, some of the sort of sacred cows of historiography.
Yeah.
I mean, some of these issues, I mean, even in a completely non-technical sense, historians go rigid with fear when you ask the question, will emails be part of historical evidence? I mean, it's got no technical question as I do. It just, either way, they feel appallingly trapped. And it seems to me what kind of emerges here is the kind of turning inside out of the historical. It's not any longer a sort of specialist explanation that the historian has a kind of copyright over. It actually becomes the way in which causality and narrative and whatever themselves are put back for kind of reconsideration. But I mean, I'm very interested in like the way in which the exhibition and the way in which their gathering of evidence, they're very obviously open to, and one has to say that sounds like a very good idea. But it's the historical and the archaeological side of it, which I think is also of just as much interest.
Yep. Well, it was Mirko that had this term, archaeology, and I mean, I hated it because it just makes me feel really old. Makes this stuff feel very old, but I think it's the right term because it is more what you're saying. It's not the job of the historian, it's more the collector, or it's more the person excavating and finding details, let's say. And with digital technology, there's the volume of stuff is huge. I mean, when we did have some of the stuff for the upcoming show, the next show, I will say we just decided to make like the worst case of everything. Like, what's the museum's nightmare? Like hydraulic pumping walls, festo muscle blobs, things that are driven by software that's been out of date for 15 years. I mean, they're really, for this next round, trying to pick every worst case scenario and see how much of it we can bring back to life. But what we're faced with is, how do you go through all this stuff? I mean, there's just so much more than there would have been if it wasn't digital. Like, there's daily saves of everything, and you don't know which one actually works. And so not that many people are having to go through all these files and sort out just tons of stuff that was never really meant to go in an archive. I mean, whereas, a lot of times there'll be like the photograph of the architect's hand on the model, and that's the one that's meant to communicate the idea. when you go into this digital stuff, there was really no self-consciousness about it ever being used for anything other than just the most kind of quotidian thing it was being used for that day. So it's very tough for a historian to figure that out. But I don't know, I can't help but think the fact that most of my students, when you ask them a historical question about today's work, they just go to a press release. You know, they go to Archinect or Dezeen or Design Boom. You know, it's just like what constitutes architectural concepts and theory right now by the architects is so much more just like press releases that happen like every week. So you don't really know like what somebody's working on, you just know what their press release was from last month. It's a very weird phenomenon, but I think it's related. I really do think it's related. I mean, I don't know, Jacques Herzog was at Columbia, I heard 2 weeks ago, everybody's talking about, he said he's totally uninterested in theory. He thinks all the architectural theory is a waste of everybody's time. And I was like, what is he talking about? Like, what does he know that I don't know? Like, why? I don't know. Anyway, I really think there's this very weird kind of big data void out there right now. That there's a lot of information, not a lot of understanding of who the audience would be, especially the historical audience.
It seems to me it's less archaeology, more crime scene. Like,
Forensics.
I think it's going to be more about forensics, sort of qualifying, I think, multiple histories. It seems to me that part of the reluctancy is what Greg's touching on, is that there's an inability to sort of conceptualize certain problems because of just the nature of I think, trivial things like email, for example, like you're speaking of, Mark, of what is a legitimate source of information and what is not. And sort of now the complexity of that is so at a magnitude and a scale that is becoming really difficult, that I think it's even more necessary to sort of put those things there and allow people actually to sort of figure out and piece together their own story. For the digital anyway, it seems like it's a bit too soon to sort of put the bow on it, because it would almost be like the last nail in the coffin in a sense. Because it would seem like somehow that there is something that one could sort of package. But if we really think about the histories of this from the mid-90s, or let's say the mid-80s, of where the show is kicking off, I mean, it's such a limited scope within the history of architecture that time is something that people are going to just have to deal with as something that actually is going to bring a new knowledge and reflection for a lot of this kind of work. And I think possibly more tangents actually just by putting these four people together, potentially, like, I don't know if Peter talked with Chuck.
I mean, I think they all were aware of each other, what they were doing.
Sure.
But there was absolutely no discussion between them. Because that's one of the things we kept asking was, you know, what kind of correspondence was there about the digital during the late 80s between all of you, and none.
Yeah, I mean, if you ask that same question to, like, let's say the generation of 2013, it would be impossible to sort of state that as a fact. So it's something that I think is really interesting and evolving. I think we're going to try to bring this one to a close. If I can mention that the book, the catalog for the first exhibition is being sold in the back if anybody's interested in that. And with that, I think we look forward to seeing where the next exhibition and show is going forward. And if we can, thank Greg for his time.
Oh no, no, that's great.